All right, so for 7.1, I'm just going to give you some definitions that deal with symmetry. And y'all will look at three types of symmetry on the graphs. So my first symmetry, remember symmetry, we're looking like the human body, the left side is symmetric to the right side and stuff like that. So for the first symmetry we're looking at symmetric to the y-axis. So for a graph to be symmetric to the y-axis, if folding the graph over the y-axis and the graph lands on itself. So it's symmetric to the y-axis if folding the graph over the y-axis and the graph lands on itself. So an example of a graph being symmetric to the y-axis. So let's see, there's my x-axis and my y-axis. So the y-axis, we're talking about our vertical axis here. So parabolas that we draw. Our parabolas are symmetric to the y-axis because if I take this graph and fold it across that y-axis, my right half is going to land on the left half. So not too bad with that. So now we'll look at being symmetric to the x-axis. Oh, y'all know, let me say this. If it's symmetric to the y-axis, then we call those even functions. Okay, so usually that means it's got even exponents later on in life. But for a graph to be an even function, it's got to be symmetric to the y-axis. All right, now getting back to the x-axis. If folding the graph over the x-axis, so we're taking it and folding it down this time. But if folding the graph over the x-axis and the graph lands on itself. So an example of that one would be, let's see. There's my x and my y. So to be symmetric to the x, it would be a graph sort of like maybe like a sideways parabola or so. But if I took the graph and folded over to x, the top of the graph will fall on the bottom of the graph. Now, this kind of function is not an even function or an odd function because this ain't even a function, remember. Remember, this would fail the vertical line test. So that wouldn't be a function. Only way I could make a function out of this is if I restricted one of the values, okay? All right, y'all, so I've used both the lines. So the third symmetry is what we call symmetric to the origin. Now, the origin of the graph is where they intersect. That's at the 0, 0 point on the graph. That's what we call the origin. So to be symmetric to the origin, if rotating the graph (180 degrees) and we end up with the same graph. So basically, rotating at 180 degrees is turning it upside down. Okay. So an example of that would be our cubic functions. So our cubic functions were the squiggly lines. They come up, cross through the origin, and go uphill. So look at this graph, how it looks. I'm going to turn it upside down 180 degrees. And y'all, that graph still looks the same. It's still going uphill from the left and up towards the right. So by turning it upside down and getting the same graph is how I check for the origin. Now, if it's symmetric to the origin, we call that an odd function. Okay, y'all, so these are the three symmetries. I'm going to now go to the mathlab and we're going to answer these 5 questions. So let me share my mathlab screen. And y'all make this a little larger for you. So y'all, I'll ask y'all this. Is this graph symmetric to the x-axis, y-axis, or the origin?
Origin?
Yo, it's definitely the origin, right? If I turn it upside down, the bottom part on the right will end up on the top of the left, and what's on top of the left would end up on the bottom on the right. So that is definitely the origin. So you go check your answer. You know how MATLAB does. So let me make this in a little larger. So y'all, this graph, symmetric to the x-axis, y-axis, or origin. And y'all, they've even got an answer that says both the x and the y-axis. So what are we choosing?
Is it A?
Let's see. A is what? Both the x and the y? Well, if you fold it on the y, it will land on itself. But remember, if you fold it over to x, there's not even a graph on the bottom of the x's. So remember, it won't land on itself if I fold it over the x. So y'all, the only one it can
Okay. So it's D then.
is D. There you go, delta. Right, remember, it's going to make us check and move on. All right, there's another one here. So what y'all saying on that one right there? It looks like a sideways V shaped. Is it symmetric to the x-axis?
Yes.
Yes.
All right, so we
Yes.
would. So watch, you're gonna put yes on that. Is it symmetric to the y-axis?
Yes.
No.
Oh. No.
Okay, so no, because there's not even a part on the right side of the y for it to land on. So that is no for the y-axis.
Okay.
Now, is it symmetric to my origin? If
No.
we rotate
No.
it 180, will it look like a V on the left side?
No.
No, because it'll land on the right side. So it's not It's not the same picture, so that would be no. Still, they're not too bad. They're just going to have you go through them 3 questions. So now let's remember what I said about this. Remember, to be an even function, symmetric to the y-axis. To be an odd function, symmetric to the origin. So what do we got here? An even or odd function?
Even.
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 And y'all, another trick. Look how many times it touches the x-axis. It touches it once on the left side and once on the right side. So since it touches 2 times, that's an even number. So that's another thing you could look at is how many times is it touching the x-axis there. So then same thing on number 5 here. Is this function even, odd, or neither? And I'll make it a little larger. So is it symmetric to the y, which would make it even? Is it symmetric to the origin, which would make it odd? Or is it neither?
Is it neither?
Oh, I'm hearing 2 things. So what'd y'all say again?
Neither.
Okay, so think about it. If you turn this graph upside down, this part that's on top on the right side would end up on the bottom on that left side.
Oh, is it odd?
So it is definitely odd because if we turn this one upside down, we would have the same picture, meaning this one would be symmetric to the origin. And y'all count how many times it touches the x-axis. 1, 2, 3, 4, 5. So see how it touches it 5 times? That makes it odd also. All righty, so that was 7-1. So now we're going to go play with 7-2. So let me do one thing. I needed to switch my page. All right, so let me go to 7-2. So for 7-2, we're doing transformations. And that's moving the graphs around. So we're going to take graphs, move them up, down, left, right, and we'll reflect them over the x-axis. So first, let me give you the basic graphs they're going to be moving. So y'all write these 7 basic graphs down, okay? Because these are the graphs that we're going to do the transformations to. So the first basic graph. So here's my X and my Y. The first basic graph looks like a line going uphill to the right. This graph is the Y equals X graph, the most basic line graph you can have. Now, often I call this the identity graph. And that's because when X is 1, Y is 1. When X is 2, Y is 2. When X is 3, Y is 3. So first basic graph, Y equals X. All right, y'all, my second basic graph looks like our friend, the parabola. So what were we graphing that gave us the U-shaped graphs? That would be our...
The even.
Or the x squared graphs. There you go. So it would be an even function for sure. And notice it's got an even exponent also. But our x squared graph is our second basic graph. All right, next I got the one that we've been playing with a little bit. It sort of shoots through the origin. This graph is our x cubed graph. So that's the one in MATLAB where you had to use that little squiggly line to draw it, okay? All right, so the next graph we haven't really messed with yet. But we will play with this next graph when we get to the third test material. But this one comes in from the left and shoots down. And then on the right side, it comes in from above and sort of hugs that x-axis. You know, this is the y equals 1 over x graph. And you see right here where the x is 0, this graph cannot cross over that where x is 0. Because remember, if you put a 0 into this fraction, that makes this undefined. And see, it cannot touch the graph or go over numbers that make it undefined. So we'll learn later in life that when you got a side that comes down like this and a side that's shooting up towards positive infinity, later in life, we're going to call that a vertical asymptote. A vertical asymptote is a place where the graph cannot cross, okay? And that's what happens when you get those undefined numbers. But we won't have to know that. All we got to know is the 1 over x graph looks like that. All right, let's see if y'all remember this one. Looks like a V. That would be the absolute value x. Because the absolute value of 1 is 1. Absolute value of -1 is 1. So that's why that graph makes a nice sharp V for us. All right, y'all, next. This one goes to the right and slowly climbs uphill. This is y equals the square root of x. Now remember, we're only looking at the positive square roots of the x. We're not looking at these negative values because we want to keep that as a function. But notice, for square roots, you don't have no graphs on the left side where the x's are negative, because in the real world, we cannot take square roots of negative numbers. That's where you get the imaginary numbers at. So that's why this graph only goes to the right side on the positive x's. And then the last one is the cube root of x. The cube root is even shorter than that graph. But the cube root can go to the left side. This would be y equals the cube root of x. Y'all, because I can take cube roots of negative numbers and I get a negative answer. Okay. I can also take cube roots of positive numbers. So you can take cube roots of negative numbers, but you cannot take square roots of negative numbers. So y'all keep these 7 graphs handy because those are the graphs we're going to move around. Now, there are 3 transformations we're going to look at. First transformation is a vertical shift. So vertical shift, I mean, it's either going to go up or down. So to get a vertical shift from your function, you're going to have y equals f of x. So there's your function, which will be one of these, x, x squared, x3, or one of those basic graphs. and then plus or minus b. So if I take one of these functions and add a number to the end of it, or subtract a number from the end of it, it's going to move it up and down. So if the b is positive, then it's going to go up. If that b is negative, then it's going to go down. So let me give you an example of both of those. If I had y equals x squared plus 2. So we're looking at the x squared graph up here that looks like the parabola. But if I take that function and add 2 to the end of it, it's going to move the x squared graph up 2 units. Okay, so notice I just throw that number at the end of my function. Likewise, if we had y equals square root of x minus 3. Now notice this minus 3 is not under the radical. It's outside of it. So by subtracting 3, this one would move my square root of x graph down 3 units. So add a number at the end, up, subtract a number at the end, down. All right, y'all, so let's look at left to right would be our horizontal shift. Now be careful, it's similar to this, but notice how it's different. On this one, I would have y equals f of x plus or minus a. So notice, we're not adding a number to the end of the function. We're changing the x values that are being evaluated for that function. Now, here's the tricky part. If the a is positive, so if I add to the x that's being evaluated, you would think that would go right, but y'all, this actually goes left. So adding to the x and then squaring it would make it go left. If the a is negative, then it's going to go to the right. So let me show you some examples of horizontal shift. So how about playing with the x squared graph again? How about y equals x plus 1 squared? So see up here, I had my x squared and I added a number at the end to make it go up. But here, I'm actually changing the x value by adding 1 to it before it gets squared. So by doing that, this will move the x squared graph. So it's still my x squared graph because the exponent 2. And it's going to move that x squared graph 1 unit left. So left 1 unit. All right, y'all, how about y equals, let's see, how about an x cubed? So how about x minus 3 cubed? So remember, that's my x cubed graph because of exponent 3. But by subtracting 3 before I cube it, this will move my x cubed graph right 3 units. Okay, so just think backwards on this one because adding is left, subtracting moves it right. All right, our last transformation is what we call reflection over the x-axis. So to reflect the graph over the x-axis, we'll have y equals negative f of x. So y'all, what that does, say all your y values are positive right here. But if I throw a negative in front of the function, it turns all these positive y values into negative y values. So see, that's how you reflect it right over the x-axis. So my example for that would be y equals negative x squared. And on that last review, if you had an x squared graph with a negative, your parabola didn't open up, it flipped it over. Okay, so what reflected it over when you had that negative in front? All these positive values became negative by putting that negative there. So what this would do, reflect the x squared graph over the x-axis. Okay. So y'all, those are the moves we can do. So they're going to give us things that look like my examples, and we're going to have to tell them what graph we started with and what those numbers are doing to our graph. So for these ones, I'm actually going to go to MATHLAB because I want to show you how to graph these in MATHLAB. So it's a little tricky graphing them in MATHLAB. So let me share MATHLAB. All right, y'all. So y'all should be seeing my number one. Describe how the given function can be obtained from one of the basic graphs. So we're going to figure out that x minus 7 is inside the parentheses. And when it's inside the parentheses, that's the horizontal shift. So by subtracting 7 from my x, that is going to move this thing to the right 7 units. So you come down here to the one that says shift the graph right 7 units, which would be D. And we got to tell it what graph we start out with. So the basic graph this one comes from is the x squared graph. So you punch your x, and then we square that. And y'all, we know that because of that exponent 2 on this, okay? So you're going to check the answer. Then it's going to make us graph that. So first, the tool for the x squared graphs is the U-shaped quadratic graphing tool. So what you do, you click the U-shaped tool up there and click anywhere on the graph. Once you click on the graph, it draws the parabola for you. But y'all, it's drawing the basic parabola. You see this little box that pops open? We got to use that to move the graph to the correct spot. So remember, we said this was going to move our graph to the right 7 units. So on my little box down here, on the horizontal shift, click that little button and move it over to a positive 7. So 6 and 7. Notice when I move that bar over to 7 on the horizontal shift, look what it did. It moved the parabola for me 7 units to the right. So at that point, you click save, and then we check our answer. Now, y'all, this is the only one where you actually have to plot 2 points. because this is the one that's the straight line. So this is the y equals x graph, and they're subtracting 4 from the end of that. Now it's not in parentheses, so since they're subtracting 4 at the end, this will be a vertical shift up or down. So since they're subtracting 4, it's going to shift it down 4 units. So you would click on B, and then the basic graph it started with was the X. All right, then you check that, and it's going to make us graph it. Now, like I said, this is the only one that we physically got a graph using that line tool. So y'all, let me grab my line tool. So I had x minus 4. So if x is 0, y would be -4. So I'm going to come down and put my y as 0, -4. And then let's say if x was 1, 1 minus 3 would give me -3. So I would go to 1 and then -3. And click it. Notice when you do the 2 points, that line was going through the origin originally for the x. Now that shifted it down those 4 units. So on this one, you just draw the line physically and then save it and check it. But y'all, the rest of them, we're going to have to use that little box to move it up and down. So let's see what we say here. This is on y'all. How can the graph of h of x equals 1 over x, remember 1 over x is one of my basic graphs, plus 5, how can we obtain that from the graph of f of x equals 1 over x? So y'all, the question would be, what's that plus 5 doing to my graph? So that'd be where I just add a number at the end.
Going up.
So it's going to go 5 up. So that would be what, my B? Now, once you check that answer, this one will give you a picture of 3 graphs. So let me make these a little bit larger. So I will say A looks like the basic graph I drew earlier, right? It's coming around the origin there. So B or C, which one of those went up?
B.
All right, y'all, B did definitely go up. Looks like C went down there, didn't it? All righty, y'all. So this one, it says, is this going to shift it right 11 units and then reflect across the y-axis? Well, y'all, you can't pick A because I didn't say nothing about no y-axis being reflected. So A and B that talk about the y-axis being reflected, you can throw those 2 answers out right away. So it's got to be C or D with the x-axis. So that very first negative in the front, that's what's kicking it over the x-axis. But we got to figure out, is it going right 11 units or is it going left 11 units? Because remember, we're now attacking the x inside those parentheses. So that'd be like the A I showed you on the transformations. So if A is negative in here, -11, which way will my graph go?
Right.
Okay, so let's see which one says right. So it looks like C, right? It's shifted right 11 units. And remember, on this one, we're starting with the x cubed graph. So put your x here and then cube that. And then we're going to reflect it across the x-axis. So these sort of start like order of operations. They do the moves inside the parentheses and they work their way out. Now, you know we're going to have to graph this, so let's see. So we're going right 11 and across the x. So remember, x cubed graph is this squiggly x cubed tool. So click it, click anywhere on the graph. It's going to draw it going right through the origin. So this is a horizontal shift. Oh, we said what? Right 11. So grab that little tab and let's take that over to 11. All right, so we moved over 11. Now, notice how it's going uphill left to right. But we reflected it over the x-axis. So it now goes downhill left to right. So that thing just flip that graph over. Save that, y'all. And then make it check your answer. So these aren't too bad. You just got to get used to the moves. All right, y'all, watch this. How can this function be obtained from one of my basic graphs? G of x equals x plus 1 squared minus 5. So I need to know what graph we're going to start with first. And y'all, I said exponent 2 up there within parentheses. So that's going to be our x squared graph. So the exponents will pretty much give it away from you. Now they're saying shift it blank 1 unit. So they're adding 1 inside the parentheses to my x. Now, when I click this little arrow, is adding 1 inside the parentheses going up, down, right, left?
Left.
So it's going to go left 1 unit. And then shift it blank 5 units. So now that minus 5 at the end of my graph. Down, up, right or left?
Down.
And down we go. Perfect. Check those answers. All right, so you got to graph that. So we will click our enlarge graph. So that was the x squared. So remember, that's the x squared tool. Click that tool and then anywhere on your graph. It's always going to put them in the origin like that, y'all. So your plus 1, y'all said moved me left 1 unit. So
I got a quick question.
yeah, I hear you.
So when you put when we're plotting it on the graph, we put it anywhere as long as we shift it the right places.
Exactly.
Okay. Okay.
Yeah. Once I click that x squared tool up there, I can click anywhere on my graph. It's always going to start it right in that origin. And now we're moving it. See how it moved left once when I did that horizontal shift? And oh, what I have a -5 at the end of this, I think. So that -5, if I go to vertical and go down to -5, see what it's doing? It pulled my graph down. So now we can tell I went left and then down those 5. And then y'all save that. And check your answers. All right, so let me tell you a little trick about these square roots. If the number is under the square root with the variable, we treat it like it's in parentheses. Just like on order of operations, you treat radicals like parentheses. Now, if the +8 would have been on the outside, it would have done another move. But this +8 is under the little radical, so it's like it's in parentheses. So they're telling us that we're going to start with g of x equals square root of x, and then we're going to shift it down, up, left, or right.
Up,
Oh, I couldn't hear that. What'd y'all just say?
up,
Okay,
Right.
so let me go to my pad a second. So I had what? G of x. So let me move that back up. So I had g of x equals square root, I think, of x plus 8. So let me show y'all. To go up, this would have been a square root of x, and then plus the 8 on the outside. This one, you treat like this thing is in parentheses. So you're attacking this x before you take the square root. So up is when it's on the outside of it. So what's this plus 8 doing to my graph?
It's gonna move it up.
Well, this one moves it up.
Ah,
Move
See
it
how
right.
it-
Square it.
See how that 8's on the outside? And remember, I'll give y'all a clue. This will be a horizontal shift.
Oh, okay.
it's left. It's left.
Left, perfect.
I was just looking at that right when you said it.
It's going to be left because it's a horizontal shift. So y'all, if it's under the radical, you treat it like it's inside these parentheses. If it's on the outside of the radical, then you treat it like the B, up, plus, down, negative, okay? So let's see on that one. So y'all said left now, and then you put in your 8 units. Now we'll check that one, and I think this one will give us pictures. All right, so let me make these a little bigger. So did A, B, C, or D go left? Now remember, these always start at the
It went left.
origin. Okay, I think you was right. What did you just say?
It went left.
A.
A, there you go. So see how A is left, B they took down, C they moved right, and then D went up. So we wanted to go with A on that one because that's the one that went left. And then, all right, y'all. Remember what I just said about that square root radical? This one says g of x equals the cube root of x plus 6. But y'all, the plus 6 is not under that radical, okay? So by adding 6 at the end, did I go right, left, up, or down?
Up.
Up.
Up. So now y'all can say up for sure. There you go. So let's see. We'll check that answer.
So just double check over the notes and reflecting back to the assignment.
Uh-huh.
Nothing will reflect over the y-axis, correct? With none of these things.
None of these will go over to y exactly.
I just want to add that to my notes. That way I
Yeah.
know.
When we get to the 4th test material, we will reflect over to y. And the way that we'll reflect over to y is if we make the exponents negative. But for right now, if you say y-axis, it will get y'all, okay?
I got you. Thank you.
All righty, so y'all, let me make these a little bigger. I think I'm going to go a little bit bigger on them. So y'all told me 6 units up. So A, B, or C?
B.
B. Looks like A looks like my actual basic graph. B went up, and then C went down. So good job on that.
So now when you say that A looked like the basic graph, that would be considered basically with it being over the origin? Origin.
Yeah. Oh, well,
I got what you said. You ain't have to go back.
Yeah.
Double
So like the ones we drew while ago. So let me pull that back up real quick for y'all. Remember, y'all, these are all my basic graphs. So that was what, a cube just now. So see, the cube, all of them pretty much go right off that center, that origin. Like this one starts at the origin, right? This absolute value touches the origin. So they all sort of are fixated on that origin until we're moving them, okay?
I got you.
All right. So let's see. We did 7. I thought it unblinked me. All righty. So what are y'all saying? Cube root of x minus 4. So it looks like it's making us do it again. So what's that minus 4 doing to my graph?
Going down.
Making it go down.
Okay, so that'd be our B on it.
Oh, I see.
Now, A, B, or C go down.
A.
Yeah, so A definitely. So this time B was my basic graph, it looks like. And then C looks like it went up. Hey, also our last one. Woo, look at that. It's got 3 moves. So let's start with the X minus 6. They always start in the parentheses first. So that minus 6 is that going right 6,
That would
left
move us
6, left
Sorry.
5, or right 5?
right 6.
Right 6. So you're going to click right 6. Then reflect it across the
X-axis, because nothing will reflect across the Y.
exactly. And then how about that plus 5 at the end?
Up.
That will move the graph up. Yeah.
All right, y'all. So you do that, check answer. And we don't even have to graph that one. We just had to know those 3 moves. So y'all, that's 7-1 and 7-2. So like I said, I wanted to keep it mellow for y'all on your test week. So what altogether, there's like 13 questions altogether, and it's basically get on MATHLAB and do your symmetry in 7-1, those 5 questions. And then you had 8 in 7-2, moving your graphs around. Okay. Now all of them but number 2 in 7.2 use a tool. The second one, you had to use the line tool. And remember, on the line tool, you physically got to come up with your 2 points. But every other one will open that little box for horizontal, vertical, or reflecting me across my x-axis. So y'all, focus on your tests mainly, okay? Because that's got 50% of your grade is coming off them tests. So let's see. Any questions on this lesson tonight? Now, Kathleen, you still needing to holler at me? Katie? Is she there? So any of y'all got any questions?
On Math Labs, when you take the quiz multiple times, does it save the best score or just the last score?
No, it will always save your best score.
Thank you.
Mm-hmm. And once you get you a good score on that, you go knock out my test and you'll get a lot better score on my test probably than you did on your quizzes, okay?
That was a good question because I was actually scared to retake the review again after I made a good score.
No. If you start out and you say you made a 95 on it, you got 19 out of 20 questions. And then the second time you just played around and made 75 or 80, it's going to count that 95.
Great.
Okay.
Will these always be reflected on the x-axis as long as there is an f of x?
Yeah. We won't even touch that y-axis for reflections until like, oh my God, next to last week of class.
Okay.
Yeah, so you eliminate half the answers knowing it can only go across the X, okay? Because I think they always put 2 with the x-axis and 2 with the y. So just throw the y stuff away and just focus on my x's, okay?
All right, I got you.
Uh-huh. But you'll know I get them on my test because y'all forget about that and they'll pick the one with the y-axis and all that stuff. So don't be that person, okay? Alrighty, y'all. So sort of a short night tonight. I didn't want to overburden you because y'all do have that test going on. Now, I will say the ones I've been seeing complete the test are doing really good on it. Okay, so knock out that review good and then knock out that test. And check your results when you're done. because sometimes, say you have to put in X not equal to 8. Sometimes people are just putting not equal to 8 and it's marking them wrong. But that's pretty close to me. So if you did something like that, email me. I'll fix that. Sometimes people put spaces in between stuff. MATLAB's picky about spaces. It'll mark that kind of stuff wrong. But you got the right answer. Email me and I can override that stuff, okay? Alrighty, y'all. So I'm gonna stop this recording so it won't take long to get this one tonight because